one of the advantages of the DICOM grayscale display function is if you calibrate all the different devices, okay, any image can be rendered perceptually similar on different devices. So you can have a monitor, you can have a printer, you can have another display, and if they're calibrated, they will perceptually, those images will perceptually look the same. It's especially important in ultrasound. Ultrasound is one of those things that as you're doing the procedure, text like changing the display. So the contrast and the brightness and get an image that looks good. The problem is then they print it and it doesn't look like that because they're changing the display and not how the unit is sending to the display and to ultimately the printer. So it's a standardization way. Grayscale display function is really important. Easy to do, goes through everything from full white to full black. You measure it, and you get a curve, and then you have different DICOM is here, okay, and an 8-bit display, which is 2 to the 8th, would have these types of different steps. So this amount of luminance difference would take up, this amount of just noticeable differences. You notice how the just noticeable differences get less and less. DICOM precision, we've got all of this. I want to get to, This is Mach Bending. Everybody should see a lighter line between each one of those grays, right? Everybody see it?
Mm-hmm.
Yes.
Is it real?
No.
Nope. It's not real at all. Our eyes fool us, thinking because of that, right at that border where it changes levels of gray, it fools you and says, we need to show a step there. Okay? So it gives you a discrete shading that says you've changed from one gray to another. Okay. Now, Mach bending can be very useful when you're looking at images, but you do want to keep it to a minimum. Your Mach bending is more noticeable when grayscale resolution causes larger contrast differences between subsequent gray levels, when the luminous range of a display is increased, causing the difference between subsequent digital display levels to be more pronounced, and when they use a matrix of pixels surrounded by black boundaries. So we've gotten away from using pixels that have black borders, which is good. So, viewing conditions. In digital world, in a film world, it's easy. You want to look at X-ray film, you can be in a bright room, dark room, unlit room, whatever. You've got a bright view box, and you can see really what you need to see. In a digital world with a calibrated display, now you have to be aware of ambient lighting. The minimum display brightness on a monitor can be measured, and your ambient lighting needs to be less than or equal to 25% of that, as measured with a light measuring device. Environmental controls, noise, and temperature. Radiologists are sitting at these things for a lot of hours during the day. You want to keep noise down. You want to keep it at a reasonable temperature. And you want ergonomic furniture. One of the things that happened in digital when all the conversion occurred was we started having what? Radiologists being injured. We never had radiologists injured unless they stuck a needle in their hand during a cath or something like that. But they were having typical injuries that you have with people who work a lot with computers. So they're having carpal tunnel,